All right, good morning, everyone. Let's get started with today's class. So as if you were able to make it into the classroom this past Tuesday, I wasn't in class, but I did send you some steps and a tutorial for you to really go through installing Git if you didn't have that yet. Trying to connect your local Git with GitHub. And this is going to be important. Is one aspect, again, that I really want to emphasize in this class is just version control and being able to use that in your machine, but also on GitHub. It's going to be important. It's a skill set that I think, a lot of times we are not trained on as frequently. People in computer science do this a lot more frequently as you would imagine. But in any case, we in applied sciences also have a lot to gain from using this for our scientific efforts. Okay, so I'm looking here in my Athens in-person class. I really, I'm going to ask this and just so I have a feel of how we went last Tuesday. Who here was able to connect Git and GitHub? If you can raise your hand. Okay. So most people, some were not able to. We're gonna go through today that last part of that tutorial. I want to go through that with you. And if you were not able to successfully connect your local Git with GitHub, I'm assuming you're not going to be able to complete this exercise, which is okay, because if you cannot complete it, it means you were not able to connect. And if that's the case, then I want to be able to help you to do that successfully. We're going to have to do that after class because each person may have a different case. So we'll set up an out of class meeting just to go through that and make sure everyone is connected to GitHub. Okay, so today my plan for today's class is on the first half. We're going to go through this. We're going to try to go ahead and go ahead and run a test to see if you are connected to GitHub. If things fail on your side, then we're going to have to troubleshoot outside of class. But don't worry, we will do that. And then the second part of the class today, we're going to get into experimentation. So really, the goal of this class is that you already have a statistics course basis, especially from the stats department. This is not an intro to stats. So I'm not gonna go through the very deep details you would see in a stats course, mostly because what I've seen when I was taking those courses during undergrad, and I hear a lot of my peers and my students mentioning, is a lot of times these stats courses, they go really deep and you kind of understand how it works, but they don't really give you the application that you can actually understand in something that is applied to you. And that is where this class comes in. So you would already supposedly have a background in some of these topics, and now I'm giving you maybe a different look at them that is hopefully more applied and easier for you to understand and grasp those concepts. That's the goal of this class. So we're going to be talking about some of those concepts in the second hour of the class today. All right, so if you go on the class website, I uploaded a couple of presentations here. The first one, so if you go on the schedule would be a lecture that was posted under the topic of last Tuesday. So that would be under the Tuesday, January 23rd topic. There's a slide deck there. If you want to go ahead and open that, I'm going to go through this on my side. We're going to be doing a live demo here that I want you to follow along as well. And as you know, you can probably, if you want to, you can follow this presentation on your side. If you want to download this as a PDF and take notes, you're welcome to. But I'm going to be following this here on the screen. All right, so, for this, I really want to show you first, check if you're connected to GitHub and already show you the workflow that we're going to be following from this point on whenever we're doing a new exercise in class using Git and GitHub. So today, the goals are check if you're connected, show you what workflow we're going to be doing for every exercise from this point on in this class, fork and clone the class repo. In this, and just so you understand, on this third point here of the fork and clone the class repo is whenever then I upload a new data set or a new partial script that we're going to be developing class, you're not going to have to manually download and have all these copies of that folder on your computer. You're just going to come on this, once you have the fork and clone that class repo on your computer and it is connected to GitHub, you just go there and do a git pull. And you bring all those updates already to your computer, so you don't have to be manually downloading things. Okay, so the workflow that I'm going to present next, and we're going to walk through together, is what I will always do when you're starting a new exercise, and is what I will expect that you do on your side when we start a new exercise. So I will tell you something like, create a GitHub workflow for an exercise called 03_CRD. This is the next one we're going to be doing actually. So that's why I'm using this as an example, because then we already set that up for the immediate next one. So, normally up until this point, whenever whenever we did these things, so if you remember of like 01 intro, 02 data wrangling, the setup that we had was in your computer, we created that folder, then we went under it, created data code outputs, created an RStudio project, and then move files into the appropriate folders, right? So that was what we were doing up until now. We're still going to do that, but now we're bringing Git and GitHub into the arena here, where we're still going to do that locally in your computer, but each one of you will have a copy of this 03 CRD on your personal GitHubs, and it's going to be public in a way that now if I want to see what you're doing, if you maybe have an issue on your code and you need help, I can go directly on your GitHub. I can see what you're doing, can see your code, can make changes and and push those changes as well. So I can help you more directly that way. So we're kind of collaborating, right? More in the sense of if we have issues, I can see what you have right in front of you through GitHub. So that's kind of the idea here. Okay, so let's walk through what I will expect that you do when I tell you create a GitHub workflow for an exercise called 03_CRD. So these steps were outlined on that chapter 12. So of course, they were not outlined with the names that I'm giving you here. You did not create a 03 CRD yet, but I think it was giving an example of something of the six. So the same steps is just we're giving it different, project names and folder names and so on. So this is a link just in case you want to, catch that up or catch up with that later. So the steps here are I think there are 4 different steps. I'm going to break them down into sub-steps. So we all do this in our own computers. So the first one is to create a repo on GitHub. So I just want to kind of have this whole slide here so we see, and then we'll move to GitHub. So when you do that, it's going to ask for a name. I want you all to have the name as 03_CRD. It asks for a description, but it's optional. So we're just not going to give a description at this point. It's going to ask if you want to make it public or private. We want to make it public. You can check the box that asks if you want to have a README file. So we want to have a README file. We're going to add a git ignore, and then it gives you a few options of the git ignore templates. We want to select the one for R, and then we're going to click on create repository. And this all happens first on GitHub. So from this point on, every time that we have a new project, a new set of folders, we're going to start on GitHub and then bring that to your computer and then create those folders that we want. So let's go ahead and do this. I want to try to keep these instructions on the view here, and also go to GitHub on a different window. So just going to go on github.com. You should be on your main profile page, kind of like what I'm seeing here. You don't want or don't need to be inside of like the class repo. So we're not talking about the class repo at this point, right? So if you are right at your page, if you're not seeing this, there's probably so if you click on your picture, you can go to your repositories. That's where it was showing for me, or I guess it was not where it's showing for me, but if you go there, it does have this new repository button. So if you're here, let's just go ahead and click new. So just again, I went to my photo there and I went to your repositories and clicked on that new repository. So then it opens up this window here. I'm gonna make mine smaller just so I can also see the instructions, but you can keep yours full page on your computer. So right here is asking for the name, right? So I want to go ahead and say 03_CRD. In my case, it's saying that I cannot do it because I have already created this. So I'm just going to make one change here on my side. You don't have to make on yours because you don't have, I suppose you don't have this yet on your side. So I'm just going to put 03CRD2. But in yours, make sure it is 03CRD. It asks for a description. We're not going to have a description here. It asks if you want to do public or private. Let's keep it public. Asks if you want to initialize this repo with a README file. Let's check that box. So a README file is, so anytime you go into a GitHub repo and you land on that page and there's some description. So you see the files on top, but there's some description on the bottom. That is the README file. GitHub, if you have a file that's named README on your files that are connected to GitHub, when GitHub sees a README file, it knows already that that's the file that will show information on that page. So if you rename a README by something else, it's not going to do that by default. It has to be named README, and then GitHub treats it in a special way when it is your landing page of a repo. So let's add a README there. Let's add a git ignore. And then if you just click on this drop-down menu, we're going to have to browse all the way or lower in this list. It is alphabetically listed or sorted. So we just want to select R. As you probably observed when you were doing that, there are many other git ignore templates. So if you're working in Python, Julia, something else, you can choose any of those or others when you're setting up your repo. I'm not going to choose any specific license, so I'm just going to go ahead and click on Create Repository. So when you click Created, notice that now you're not on your main page anymore. Your main page is / the name of the repo that you just created. You see that in these files here that at this point are only living on GitHub. You don't have them yet, or you don't have them yet in your computer. There's just in the GitHub right now. You have this git ignore and this README. And I guess for now, that's all I want to show you. But now we're going to bring this to your computer through R&R Studio. So that would be the next step. So I'm going to advance here on my presentation. The next step here is going to be to clone your repository. I'm just going to play all the...
Dr. Bastos?
Yes.
Just one quick question. What's the function of the git ignore? I don't know if you went through it. I didn't hear.
Yeah, that's a good point. I don't think we talked much about it. So git ignore would be files that you, and this is really, the git ignore really works locally, like in your computer. So if you have files inside of this project here that you don't want Git to keep track of. So let's say if you have, a Word file. Word files are normally, even though you can keep track on Word files, but they don't look very nice, and can give you issues sometimes. So if you do have a Word file that you're writing a manuscript, it is in a Word file, and it is in the same project where you have Git initialized in your local machine, you can add the path to that file or that file extension inside git ignore. And then Git in your computer is going to know that it should not keep track of that file. So every time you do a git stage, a git commit, that file is being ignored, is not being kept track of. And this sometimes is important as well. So one of the things is on our class repository, I add on the git ignore part of it some scripts that I have already completed, but we have not completed in class. So I don't want to give you the complete version of a script that we have not gone through in class yet, because that then, I guess, makes you to really come to class, pay attention, develop with me, and then only get the complete version after we finish in class. So I add those under the git ignore, but it could be really any file that you don't want Git to keep track of in your computer, which also means when you push to GitHub, is not going to be reflected on GitHub either.
Awesome. Thank you.
Yeah, thanks. Okay, so let's clone the repo here first, so for doing that, if you're still on the page of where you're just created this repo, you would still click on that code button like we did when we were copying or downloading before. Now, the main difference is that what we were doing next before we were downloading zip. Now we're not gonna do that anymore. If you followed the instructions and the recommendations of that Git or the tutorial from last class, I'm assuming that you set up your token key using HTTPS, because that was the recommended. If you did that, here is already selected HTTPS. You would just click on this button and copy that. If for some reason you decided to set your token using SSH, which it was not recommended, but you had the option, you would then click on the SSH button here and then copy that link instead. On my side, I did HTTPS, so I'm gonna go back to HTTPS and copy that. So when you click here, it copies that path to your clipboard. The next step now is gonna be using RStudio project. So the tutorial that you were following was very specifically made for an R/RStudio user, right? So if you're using other languages that you're not going through RStudio, this workflow here would not, what I'm gonna show you would not work. And really the benefit of going through these steps is that it kind of helps you to avoid some pitfalls. So sometimes if we're doing this, let's say, if we're doing the steps that we're going to be doing next, if you're doing that through the terminal, there's going to be a few more steps there that you have to do that are in RStudio projects kind of hide away from you and make that simpler for you. But that's the reason why we're going through RStudio projects. If you're already used to using Git, in GitHub, you may have been doing this for the terminal. That's great. You can keep doing it that way if you want. But I do want to show you the simplest, easiest, most error-proof method that we can, which is going to be this next one here. So I'm just going to play all the steps here. So what we want to do is now on your computer. So we're still at this point, I'm going to just minimize my browser because we're not going to be using it for the next step. At this point, you just need to launch RStudio. It can really be any RStudio window. Let me just close some here then, so I can open some that look more like what you would see on your site. So it could be any, it could be a project none, like what I have right now. It could be, it could be already inside of a different project. It doesn't really matter. You just need to have an RStudio window open. And now we're gonna click on, so if your RStudio window is not of any particular project, you're going to be seeing project none. If you are in a specific project, that's okay. You don't have to move, but you're going to be seeing the name of that project on top here, as you probably already are familiar with. So just click on that right top, whatever that is for you. In my case, that's project none. Let's create a new project, or let's see here. Yeah, we can, so I think here is just showing a different way to get there, but it's basically, we can click new project as we've been doing already. And before, what we were doing, if you recall, is we would click on the existing directory path of way of creating a project. In our case here, now from this point on, we're going to click the version control option. If you come here, you should be seeing this Git option here. If you are not seeing, then maybe your RStudio it doesn't know where Git lives in your computer, so it's not showing you that option. So let me just take a moment here and ask. If you are not seeing Git at this stage, please raise your hand and let me know. Okay, I think everyone is seeing Git. So let's go ahead and click on that Git button. On this repository URL, that's where you would paste what you copied, that address, HTTPS address you copied from your repo that we created on GitHub. So that's where that would go. The project directory name, we can just leave that empty. And now on the create project as subdirectory of, I want you to click to browse there. And this is going to be different for different people. You know, the place I want you to be looking at or to browse, navigate to is the main folder of our class that lives in your computer, right? So in my case, you know, that the name of that is like 2024 CRS 8030, so on. I have that intro, that 02 wrangling. I already have the 03 CRD because I was doing that exercise on my side. You don't have this yet. So this is the folder you want to be seeing when you click open and you set that directory for you.
Hey, Dr. Bastos, quick question.
Yes.
When I pasted my repository URL, it automatically put 03 CRD as the project directory name. Is that fine?
Yeah, that's fine.
Okay,
Yeah,
just making sure.
mine is not doing that by default, but that should be fine. You can see how mine looks afterwards, and if it looks different from yours, then maybe related to that, but I think it should still be the same. Yes.
So we select folder, it's the main folder. For example, it's from the year case available ones, not the CRD one, but what about?
Yeah, so for me, let me just let me get my face out of here. So you want to be at the level of the class, the main class folder, right? So you don't want to, it's because you don't have yet the 03 CRD as I have, right? So this is where you will want to be at this level. So once you do that, so if you have a project none here, you don't really have to say open a new session. If you have a project that you're open, that you're doing this, I would say click this, open a new session, because it's not going to close your current projects. Our studio window is going to open a new one if you have this checked. So let's just go ahead and do that. Yes.
So for clicking the version control, I can see Git, but when I click the Git, it says Git was not detected on the system file.
Okay. So yeah, we're gonna have to troubleshoot that later. So it's probably that. So did you install? Were you able to install Git Bash? Yeah. So that's why. Yeah. So if you follow the directions of the previous class, yeah. I mean, if you have not gone through the steps of the previous class, then this would not work, most likely, unless you had a Mac. Okay. So if you did that and then you clicked create project, it did launch a new, or for me, it did launch a new RStudio window. I want to close the previous one, so just so we don't get confused. So we launched the new one and look at what happened. So if you, well, let me show you something here that may be actually useful. So if you, oh, for some reason, for me, it's putting that inside 03 CRD. Not quite sure why. Maybe I browsed to the wrong place.
I think that's why I asked the question.
Okay. Yeah, so I did browse to the wrong place. I mean, I hope that you all follow what I said, not what I did. But I did, yeah, I was in the wrong folder. Yeah. Thanks for pointing out. I didn't realize that I was doing that. But anyway, so if you should be straight, your 03 CRD should be right under the class main folder. And what happened here is you see that it already made behind the scenes, it created a project and already made a clone of that GitHub repo on your computer. So you should already be seeing here on the main files of this project that we just created, in your case, 03 CRD, so you don't have the 2 in front of it. There's already a git ignore, you're already seeing the project icon, and there's also a readme.md here. And this is all coming from GitHub, right? You did not create this locally. It was all created on GitHub, and you brought it down to your machine. If that happens successfully, it means you are connected to GitHub, right? Because we were able to make that connection here and bring those files already. Well, if you did not follow the tutorial in the previous class, I don't expect that you would be able to do this. But if you did follow the tutorials of the previous class and you were able to get everything in place, I would expect for you to have been able to do this step. Was someone that followed the tutorial and was not able this did not happen with you right now. Like you were not able to connect as we're seeing here. Okay, so I'm not hearing anything. So I'm assuming that everyone that followed the tutorial from previous class was able to get this through. All right, I just want to make this smaller again. Also, you know, I want to, I just want to also show you that if you go to that folder that you created things under, so I'm just going to navigate to that on my side. Your path would be different, but yeah, if I had selected the correct folder, I would be seeing 03CRD2, which in my case, I had a 2 because I already had previously the 03CRD. I would be seeing that here, right? In my case, I did put that in the wrong place. It is inside of here. But if I go inside of that folder, I also see those files in my computer, right? Of course, if you're seeing it through RStudio, it's because they're also in your computer, but I just wanted to make sure that you could navigate to that folder also on your folder management system. All right. So now let's just make a test here to really fully see that. So we noticed that what it did right there was a git clone and a git pull. So we cloned that repo to your computer and also pulled everything that was in that repo online to your local machine. Now let's make some changes locally and push to GitHub. So the next step here is if you still have that project that we created up here, you should be seeing the readme.md. So MD is it means markdown, is a file type that means markdown. Just to give a little bit more context, R markdown is a R specific file type that is basically a mix of R language, but allows you to also write in markdown language. Markdown language is just a way that we use to be able to like format specialist pages that go on websites, or just add some different format. It gives you the option of making formatting of like mathematical equations or things like that a little bit easier when you're programming. So that's what Markdown is. It is independent of R, and R Markdown is the R version, I guess, of mixing Markdown and R together. Okay, so if you click on this readme.md, this is what it would open up for you. So I quickly want to come back to my REPL just to show you here. CRD2. So we saw a little bit of this already in class, although I did not give it a lot of emphasis. So on Markdown, R Markdown, or Quarto files, they all follow a very similar way of doing some things. So for example, here we saw that if I have a one hashtag symbol, that is basically a heading 1. And that's what kind of looks like here, that this is a title on this page. That's because of that. Right, so if I just come here and leave that title, that's fine if you want to leave, or even if you want to change, you can do it. But what I want to do is just give like a very short description of what this repo and this project is, right? So let's say I'm going to write this. You don't have to follow exactly the same, but this repository is intended to run analysis of variance for a completely randomized design. Right, so just a very quick, I guess completely, I missed that spelling. Just a very quick description of what this repo is. A lot of times, once you start using more GitHub, you're gonna see that this README of every GitHub page may contain more information. It may be a lot more informative. It may be a tutorial with vignettes. It may give you links for other things. So this is where that README is what appears on that first page of that repo. Okay, so once you wrote all that, let's just click on that save button in your RStudio. Let me just come back to my notes so I follow. Okay, so the next thing here is, in my case, I am not, so on my environment panel here in RStudio, I am not seeing a Git tab. You may be seeing on your side, and if you are, that's great. If you are not seeing, let's make that the Git tab appears right next to environment right there. So we would basically come on view and click on show Git. So if you do that, your Git tab is gonna populate right there. And then we're gonna be using that to stage, commit, and push to GitHub. So next we see here that there is a column called staged. If you recall, and if you have been using Git and GitHub, the way that works is you make some changes locally, you stage those files that you want to take a snapshot of, and then you ask to commit, which is basically taking that snapshot of those files. The reason why there is this intermediate step of making changes, staging, and then committing, like why wouldn't we just do making changes, committing? That sometimes, let's say that you have a file here that maybe you're not keeping track of yet with Git. You just create a new file and you're not keeping track of that file yet. And you don't want to keep track of that, but you have not added that file into your Git ignore yet. You can, so I changed two files, one that I want to keep track of, one I don't want to keep track of. So I just staged the one I'm keeping track of, and then I commit. So the other one I don't want to keep track of is not part of that commit. That's why there is this staging area, this staging phase of the workflow. I normally prefer the mindset of if I don't want to keep track of something, I add that file path to my Git ignore, and then I always stage everything when I'm working. That's the workflow I follow normally. Anyway, so here, we can stage either our project or the README. The one that I want to stage here that I made changes and I want to commit them is the README. So I'm just gonna click on that button for the README. And then there is this button here, this check mark button on top that is to commit. So notice how we're doing all this by point and clicking pretty much. You could do this directly on the terminal using Git commands if you wanted. Yes.
So why didn't we? Mine is working on art script, not art master.
Okay, so you probably, let me go back here. So probably when we launch our studio, maybe you just launched R, and then R by itself does not have all the R studio capabilities like the project and so on. Oh, okay, let me come quickly take a look and see. Oh, yeah, remember. Yeah, okay, so. Well, okay, so the README is this one, yeah, so like, you just click on it, then you just make changes. Yeah, so we can just add whatever here, and then we're working right now, like it's on, so that's where we go. Yeah. Yeah, is everyone else able to get to this point? Yes.
I can't add that view after that, I didn't find so it.
The view, you want to not show up in yours? And you did install it. Yeah, that's right. Okay, so let's do the vote. I want to. Okay, let me adapt a little bit to help you. All right, so my intention was not to expose you to the terminal today. Just to make things a little bit more sequential. I do want to take a quick detour here, because so Benita is having an issue where she doesn't have the Get tab appearing here, and when she does go on the view, she does not have a show Git option. So Benita, here on a Mac at least, it shows me the shortcut to, in a Mac, it would be Command F1 to show. What's that?
Control F1.
Control F1? Can you try Control F1 and see if that shows your Git pane? No? Okay. All right. Control function F1? No? Okay. Yeah, so, we did a little bit of troubleshooting, and I'm not quite sure why it's not showing for you. So because it's not showing for you, I actually want to show you all. I mean, I'm going to show everyone, even though if you're not having this issue, which I think is just Benita, you don't really have to do these things because we're already doing them by pointing and clicking. But I want to show so Benita can see. So if you RStudio also, so it gives you the console. So console is where R lives, right? So that's where when you type R code, this is where it's going to be interpreted, is in the console. But you may also be seeing this terminal window right here, which is your command line terminal of your computer. Again, I was trying to keep you away from that for today at least, to not get you too much information, get you confused. But Benita, since you're not seeing your Git pane, I want to show you what I would do instead if I were doing through the terminal, or in your case, command line. I think you can see the terminal, right?
Yes.
Yeah. Okay. So what you can do, so there's one thing that maybe you can try is just type git status and run that. See if that tells you something. Can you say that again? I couldn't hear. So you did git status and told you that? Okay, so maybe there's something going on with your Git installation.
Are you doing on OneDrive?
No, I just sent into like, the neutral drive.
What do you mean the
No,
problem?
I'm not doing a OneDrive, it's under neutral drive.
Okay. So that tells me that even your terminal is not responding to Git. So maybe there's something going on with your Git installation, or RStudio knowing where is your Git installation. So I think we're gonna have to troubleshoot it later, if that's okay. So if you can, at least keep following as much as you can. I know we're not gonna be able to do Git on your side, but at least if you understand what we're doing, when we do get yours connected, it should work fine. All right, so here what we did is basically a Git stage, but we did that by clicking on the button, right? So we just staged README, and now the next step is we want to commit. So if you're clicking, it would be that button right there. It's like a check mark. That's the commit button. It's gonna give you a pop-up window where it's gonna ask for a few details. So we have that, we see again, README is staged. We have this commit message window, and something I really want to encourage you to, with commit messages, is try to write a message that is informative to you, especially to your future self, yet is short, right? So don't just say like updates. That's really broad, right? You don't know what you're talking about. If you read that, you're trying to understand what happened, it's not gonna help you. So here, something that would be informative and short is probably like updated README, right? That message is short, sweet, we know what it is, and it's informative. Also, if you look below here, this is what Git is doing, is it's showing you the README file, and it's showing you the difference between its original version and what you are doing. So what we did here is basically add this line of text, in this case, it's not code, but it's showing that you made that is the difference between the previous version and this current version, right? So remember that Git is taking these snapshots over time and telling you what's going on there. Okay, let me just come back to make sure I am. Okay, so then next we just click on commit. So we're making that commit. You see that there is something going on here on the terminal. And then we can just close this log window here. And you can go ahead and also close this this commit window that opened that we just used.
Hey, Dr. Bastos, quick question.
Yes.
On that window that you just had up, I saw a button that said pull and push. Could we have clicked push instead of commit and it sent it up there?
We're gonna get there. So the workflow, the way it works is you make changes in your computer, you stage those files that you want to keep track of the changes, you commit those changes. So the commit is the actual snapshot. And then there's the push step, and that's the one that sends the changes you made up to GitHub. So that's what we're going to be doing next here.
So the changes haven't been sent up yet. It's still local?
It's just local. Yeah.
Okay, okay.
So and you can even, you know, I mean I can show that on my side as well. So if I come here on GitHub right now and I just refresh my page, it's still the same, right? The changes are only local. I have not pushed them yet. That's what we're going to be doing next. Okay, so we made some changes locally. We staged and committed those changes locally. So our Git locally has taken a snapshot of that, but it has not reflected yet on GitHub. The next step now is to push to GitHub. So if we go back on that Git pane that we were using, let me just resize my windows here to make that a little bit easier. So if we go back to that Git pane that we were using, you see there is a green button going up. That is the push, Git push action. So when you're pushing, you're making your changes go up. It's like uploading your changes to GitHub. When you're pulling, you're bringing what's on GitHub to your computer, right? So you're making a copy or you're downloading those changes. So now we want to push these changes. So go ahead and click on that green button. It's going to show you some messages there. And I think that's it. So we can go ahead and close that window. And now if you go to your GitHub page and you refresh it, your changes are reflected there. Okay. So this means that you are connected to GitHub. The changes you make locally, as long as you stage, commit, and push, don't forget to push to make them go up. Yeah.
Is asking me for adding in the username. So that would be the actual GitHub repository name, or like the name with which I created my GitHub.
So I remember we did that step on the tutorial, and I remember there was a place where we just gave your name and another place you have to give your email. And I right now I don't recall which one that would be. I would say just give your GitHub email, because either way, that's gonna, so the email that you sign up to GitHub, because that's gonna at least make sure that it goes through. Okay, want to take a quick step back here and just check. Of those of you that were able to get in, so I know that you guys were not able to get to this point but oh, you did?
I again go into my OneDrive, and here I can see my slow chart. But if I go on other outside OneDrive, I can't see that.
So the Git tab only shows up.
OneDrive, yeah.
Okay, so just let me see if I understood that. So if your files are in OneDrive, you see the Git, and if they're just in your computer, you don't? That doesn't make sense. I mean, I'm glad it worked, but yeah,
Or then I can't sit in class because of OneDrive, so I start working outside from this class, but now I can't see that.
interesting. Huh. But so were you able to make all this work on your side? No?
That's the option, but after that, I don't see my repeat file on the bar. I can only see my project.
Okay, so if you come here on the Files tab and then you click on that R blue button, you don't see
So
all your files. So,
see all those files, but under the environment, I can't see my review files.
well, have you made changes to it? Because you wrote some extra lines on your README and you saved on the computer? Okay,
Same line.
okay, huh. Well, let me just take a brief moment to see how you guys are doing. So,
Yeah, I haven't saved that, so.
Okay. yeah. All right. Were you able to?
No, it's sad.
So try to give it your.
This username or my repository?
No, so what I would try, yeah, it would be, have you tried this one?
Yeah, I have tried this one and I have also given the password, but it says like wait.
Did you set up the token key as with the tutorial?
No, I guess.
Oh, maybe that's why.
Oh, we haven't set up your. Yeah.
So the next thing I would try is to give the email that you sign in. So let's try that. Okay, and now you get that email for GitHub.
You have to create it, right? You have to do every time for each your.
That's how it says on.
Yeah, we're gonna have to go back to that because you're gonna have to go back and create your token. Benita, does that work?
Go back to OneDrive.
That makes no sense, right? Because to me, it seems if you are in OneDrive, it will give permission issues.
All my, I can't save my data.
For,
Unless I have saved already, it doesn't find the file.
okay. Like not for only this class, you're saying, like even for your analysis?
That one, like you seem to be.
Okay.
21.
Okay,
I grab how to run, but I think I can't save all the training.
that is weird. You may not have permission to write to your OneDrive, or maybe our studio doesn't have permission to write to your OneDrive.
No, I'm doing it in OneDrive now.
You are? Well, talk to Arminder later. All right, okay, I think, well, so, we were trying to troubleshoot some cases here. So for this to happen seamlessly, which I hope it did for most of you, you did have to install Git. You did have to set up or have an account on GitHub, which you all do. You had to set up your token, which there is a part of the tutorial that walks you through that. And I think that's it. So if you're not being able to get to this point, one of those steps did not work for you. So then I can follow up with individuals after class, so we can keep moving. Okay, so besides you guys, well, Benita was able to get it. I know, are you trying to? Yeah. Yeah, I think that's probably something you have to do after class. But for everyone else, did it work? Okay, awesome. This is cool, guys, because especially, I know my students have been to get in GitHub workshops before. And when you're doing this through the terminal, there are more chances of things going wrong. And by going through our studio, that kind of is packed away from you and it kind of abstracts some of that complexity. So hopefully it works more seamlessly in this case, which I think it is the case for most of you. So if your changes, whatever you made here, are reflected on GitHub, if you come and refresh that page, then you're good to go. You're connected. Okay, so if it did all work, great, congrats. We're good and set up for all the future exercises. If not, then please follow up with me, send me an email. We can set up a Zoom call or a in-person meeting to go through this. Okay, so if you are connected to GitHub, the next thing I want us to do is to fork and clone the class repo, which is that 2024 DSA one. Once we do that, you're not going to have to manually download that anymore. Every time I send you an email saying, hey, uploaded a data file and a partial script file, go ahead and pull it. You're just going to go to that folder on your computer, launch that RStudio project, do a git pull, and you're going to be fine. So there are some detailed instructions on how to do that here. I think I also provide those instructions so we walk through together. So the first thing is to copy that URL. It's not the actual URL like we see here. It's going to be on that code at HTTPS copy URL. So I'm just giving you here the URL of the class so you can click on it if you're following the presentation on the website. And if you're not, I hope you already have a link for this somewhere in your computer. Let me actually do this on another window so we can see that. Side by side. Okay, so on the right-hand side here, I am on the repo of our class on GitHub. What you want to do is basically just click on that code button, have HTTPS selected, which is by default, and then copy that address right there. Okay, so we copy that. The next thing is we're gonna fork and clone with a package called use this. So again, everything I'm showing you here, there are ways of doing all this differently, right? You could be doing this on the terminal or command line. You could be using another IDE like GitHub Desktop is one option. You could be using that. I'm showing you what I think is at this point the most straightforward. But if you're familiar with these steps and you're used to doing this on the terminal, feel free to do that. But if you're not, then I do want to show you one option that I think is going to be easiest on you. So let's do a clone or a fork and clone of that repo from the class. So what we do there is if you have any RStudio window open, it could even be the previous one. We can just go there. There's no problem. On the console, so on the bottom part here, if you were in the terminal, make sure you go back to the console. Again, the console is R specific. That's our code that we run. The terminal is not R, right? The terminal is going to be Git. It's going to be, I mean, you can run R in Python or R in Python from the terminal, but most people don't do that, I guess. So you don't want to be on the terminal. You want to be under the console. And if you don't have the presentation open on your side, I think it may be best if you do that now, because I provided you a piece of code here that if you have the presentation up, you can just click on this button to copy that code. And then you can paste this on your console. So what we're doing here is using the package called use this. If you don't have this package installed yet, I think you probably do if you follow the tutorial from last class. If you don't have this package installed yet, you're going to first have to do an install dot packages use this. You're first going to have to install that package if you haven't yet. But if you have already installed, or after you go ahead and install this package, you can just copy this code that I have on the slide and paste this on your console. So if you notice, I already did a little bit of that for you. So the URL that you copied from GitHub, I already pasted as this part of the code, or that second line of the code on the presentation. The next line is the destination directory. So this is where in your computer you want to save this this GitHub repo of our class. This path you're going to have to change. It's going to change depending on each of you. What I would say is if you come here on the desk there and you keep that tilde and the /, but you delete the rest of it, Don't delete the closing quotation marks though. So if you're at this stage here, so that tilde forward slash, at least on Macs, and if it doesn't work on Windows, let me know. If you hit tab at that point, this is going to, so the tilde forward slash puts you at the root of your computer. If you hit tab after that, you're gonna be able to navigate from the root upwards. So in my case, if I wanted to navigate to where my class is, I would come on desktop, I would hit tab again. I would come to Google Drive, which is where that is, hit tab again, and so on. Yeah, I want you to navigate to where your folder on your computer is for this class. You want to be at that main level again, right? So let's say for me, it would be the folder. This is where I would be in my case. And I just want to show that folder in my file system. So maybe that's also helpful for you. So this is the folder that you'll want to navigate to, but you need to get there by using this style here, right? So we're basically navigating that folder in here in this argument. I want to give you just a moment to get there. And I do want to tell the next thing here is you see there's an argument called fork, and I set that to true. I think the default here is false, and if fork equals false, it just clones the repo. If fork equals to true, it clones and it forks and clones the repo, which is recommended if the repo is not yours. Yes.
When trying to specify the path for the folder. So with that to the side and the forward slash, yeah, line, tab line takes you to a certain folder, like my documents folder. What if I wanted to come out? Is it the same thing, the two dots?
It should be. So if you have the tilde forward slash, that should take you to the root of your computer. So I don't know if you go up a level, I don't know if there's gonna be an upper level. Maybe there is, but it should be at the root. Let me,
If you want to go one level up, it's up forward slash with two dots, right?
yeah, so dot forward slash is gonna take you up a level.
Hey, Dr. Bastos,
Yes.
I'm having a slight error myself. Only thing I see this desktop when I use the tilde backslash is it says desktop.ini. I don't really know what that means, and it won't let me go any further once I click that. Like that's just it. So I don't need to know if I don't know.
So he's telling you desktop of what and what?
Desktop.ini.
I. Okay. Huh.
And then if I hit tab to like go any further, it won't let me.
So what happens, let me see here. I'm not sure what happens on my side, but if I just have the quotation marks and I hit tab. Okay, we can also do this. So if you, so the way that it was being shown on the tutorial was to start at the root and navigate down, right? So, or depending on how it look like I edit, but let's say you start at the smallest level and you want to go deeper into the system. That's the approach we were using, right? That's an absolute path. Let's try instead to do a relative path. So starting where you are and then going back instead of forward. Yes. Yeah, okay, so if you, were you able to follow the tutorial from last class? Because if you were, I would think that you already have the use this package. You can try, so let me just delete this. So to check if you have the use this package, you can just do a library, use this. If you have it, you're not gonna get any issues. If you use library, use this and says no package was found, then you have to install it. Yes. Yeah, so it would probably be on that same folder. But I don't think now it's gonna be, I don't think it's gonna say main when you do the clone, the forking clone.
It gives error exists or is not an empty directory.
Okay, so it already exists. It's giving you that error because you already have. Okay. So, okay, let's change the plan a little bit here then. So if you recall, the goal of the 2024_DSA when you were downloading it was that you would not keep your own files there. There was just a place where you retrieve files and then move to your actual projects that we're working with, like 01 intro, 02 rain. With that, you should be able to simply go ahead and delete 2024_DSA that you have downloaded previously. You can just go ahead and delete it because what you're going to be forking and cloning is the same as what is on GitHub right now. Assuming you did not save your files under 2024_DSA, which is what I was recommending for you to do, right? So you just go ahead and delete that because that copy you have right now is not connected to GitHub. And to get it connected, it would be a little bit more complex than doing this. So
You have to delete the folder that's already there.
yeah, the one that you downloaded manually, you can go ahead and delete that. Did it work? Okay, nice. That's good. We're working at getting GitHub and setting up when things work. That's a good thing.
Yeah, it works for her too.
Okay. Nice. Usman, were you able to work through?
Yes, they have the library.
Okay.
Next, we have to.
Yeah, so now, so if you have the package, then I would recommend that you open my presentation, which is on our website, and you just copy this piece of code and paste here on your console. And it could be from any R Studio window. It does not have to be any specific window. And then here, I already left you the HTTPS address that I copied from GitHub, and then you're gonna have to change the desk there. So I know, so Austin was having some issues, and let me just recap one thing here. If you're having issues with the desk there and finding our class folder, I just want to repeat this. So right now, the way that the tutorial is working is starting at your root and going down your folder structure. That is a absolute path, right? And we normally, when we're working with our studio projects, we avoid absolute paths because they're different for every computer, right? So that's why we use the relative paths instead. Let's try to do relative paths instead, in this case as well, if you're having issues navigating to your course folder in desk there. So to do that, so you can just delete all the text that was within the quotation marks. If you hit tab right here, if you have a cursor blinking there and hit tab right here, it's going to show you where you are in your computer, which it may still be different for you, but for me, I am inside of the Git repo local version that I have for 03 CRD. If you remember, that folder is inside of your course folder. So if you're starting under here, you want to go a level up. So we do // In my case, I'll have to do it twice because I created this in the wrong place. But this is the main folder for me, at least, of the course, right? So instead of starting at the root and going deep, I started deep and went a level up. So you can also do this if you're having issues with the desk here and navigating to your
You have to go 1 4 back.
One more?
Yeah, because then it will put in that folder.
So you went to this level?
Yeah. So your DSA 2024 will be copied in this.
Well, but so for me, so right here, I have all the courses that I'm teaching, right? So for me, that's not where I would like to save it.
No, but you have to select which course you are selecting, teaching here. So you're teaching this, yeah. Now it will go there.
Okay. Okay. So you can try that on your side, but make sure that you can navigate to that point. And once you run this, so you click enter or return on your console, this is going to apply and it's going to create that copy for you.
So Dr. Bastos, what folder are you wanting us to put it in specifically? Because it would work better for me doing the .. Like, which folder specifically do you want us to drop it into?
So you want it to be at the, so let me do that again for my case here. So if I hit tab, I am in a place that I should not be, so // I go a level up. In my case, I have to go one more level up. And so what some students here are saying, I thought that if you just kept like this, so if you're seeing the 0, 1 intro, 0, 2 wrangling and so on, I thought this level would work, but it seems like it's not. So I guess you go another level up and then browse again inside of your folder. Oh, sorry, that's different. So you kind of like go past the level and then come back to the folder of the course. Does that make sense?
Yes, sir. So I've got I keep my classes I'm taking for each semester split up. And so I've got the whole entire class folder for you selected. So that's fine.
Okay, that should be it. Yeah.
Awesome. Thank you.
It can be different for every, right? Like the path.
Right, it's gonna be different, yeah. Yeah, so just, as long as you start empty and hit tab and see where you are, you're probably gonna have to go back up a few levels doing // and then you get back inside the class folder, and that's where you would be, yeah. All right, so let me ask around. Who was able to fork and clone successfully in the right place? Okay, so some people did, some did not. Chris, how's the process going?
Yeah, I was able to get it working on.
Okay. Okay, nice. Well, I guess you're not gonna be able to. Sundas and Eva, what are you guys going through? You got it? Okay.
So I think you have
Oh, yeah.
Yeah, I think because you still have the two-day was. So that should be. You want to hit enter, have the honor of hitting enter, and see what happens. Okay, I think it works. Yeah, so this is where you want to be. This is your console. That's where you want to. Do you assess thinking or something? That is that, you know, do HTTPS. No, you have to copy Dr. Pastor's this, as a. Because you copy it now. That is only, that is that, HTTPS. The person access open. Yes, that's true, but you have to, really think HTTP, move Dr. Pastor's and copy. SSD and keep pressing. So you set up yours as SSH. Which one will work?
Yeah.
No, does it still?
I'm still figuring out the personal access.
Oh, yeah, okay. So, all right.
Okay, so I think, the people that had things installed, I think we're able to get through and to this point. Those of you that were not able to get to this point, please let me know today so we can follow up and because we're gonna be using this from this point on. All right, so so now anytime that I do upload new code or or data files, all you need to do is you would go on that RC, oh, well, let me show you here. So this is how it looks on my side. I don't know if yours is saying 2024 DSA or if it still says 2024 DSA main. DSA, okay. So what you would do is you would come here. You know what? Actually, this is not an RStudio project, so I have to edit this. So let me show you. So we're not going to be doing that through our RStudio project because my 2024 DSA does not have an RStudio project created, and that was by design. So what you actually have to do, and I will change my instructions to reflect that.
We have,
That project.
because when we.
You have?
Forfeit, it will be.
Okay, nice. Okay, so it did create. All right. So you basically just launched that RStudio project that you have there. And again, you go on the Git pane. And then you just hit that green blue button facing down. That's the Git pull. So when you do that, you're gonna get the copies of the new files directly into your computer. Okay, so let's say I go and I upload something new. You come here, you launch your local RStudio project for that 2024 DSA. Just to not get you confused, I'm showing here for 03 CRD, but you should be on the 2024 DSA projects. You go on the Git pane, and then you click on that down button. That's gonna bring all the updates from RStudio, not from RStudio, updates from GitHub. And then once you go on your actual file system of your computer and you click on that folder, the files will be there. So you don't have to go to GitHub anymore, click download, unzip, and all that. It's already, you're just gonna do a git pull, it's gonna come automatically to you. As a refresher, this is just an easier way for you to retrieve the files. You're still gonna have to copy those files and move them to the actual working project. So the 03 CRD is an example, right? So just as you were doing before, you have a new data file here, copy that, you get outside of this, you go on the actual project that we are working on in class and paste it there, right? So there's still that step that you can do manually, but at least if downloading is going to be automatically through git pull. And all this is described here, so you can follow the instructions there if you ever need to get back to this. Okay, so just to recap then today, we created a GitHub repo of 03 CRD. That's the next exercise we're going to be working with. It's not going to be today, may not be next Tuesday, but it's the next one that we're going to be working when we get back to coding. And I still will upload the files for this on the class repo for you to git pull and move to the 03 DSA, or sorry, 03 CRD. So it did that. We forked and cloned the class repo. So now you can git pull from that. You don't have to be downloading manually. And that was it. It seemed like it was not a lot, but we actually did quite a lot in those 13 slides right there. So this wraps up this part of the class. From this point on, we're going to be using, so the fork and clone, you don't do this anymore. This is just once, right? This is to get you set up. But what we did the first part of this lecture, which was creating 03 CRD on GitHub, bringing that to your computer through RStudio, that we're going to be doing each time we have a new exercise. And I will help you. I will give you that information once we actually get through it. So you get some more directions. But I hope that this is kind of making sense. And if it's not, it's normal because it is a lot of moving parts. But it will make sense by the end of this course because we're going to be doing this a lot of times. Okay. Any questions at this point? Yep.
We have to move our data from the previous one to this new file, right? Which we just put in.
So the previous ones that you were downloading by hand, that you can even delete if you want. Because this is going to be in place of that, right? Yeah. Okay, any questions about Git, GitHub, RStudio, anything that we talked about up until this point? All right,
So anytime, and just to make sure I'm on the same page, I think I've got mine set up properly. That you said that you've added a new script. All we'll have to do is click the, go into our RStudio and click the pull button from the Git tab.
that's right.
Awesome.
So the RStudio project of the 2024 DSA files, right? That's where you pull the data and then you copy and paste those data into, let's say, the 03 CRD folder. That's where we actually develop that script. Does that make sense?
Yes, sir.
Okay, and next time that we do coding, we're gonna do that together, so we all are on the same page as well.
Awesome.
All right, any other questions before we move on to experimental design?
The message.
Yeah.
You did create that CRD folder inside your project, right? But when we pull it, why are we seeing it here?
So the 03 CRD, each one of us should have a copy of it. Like a different copy, right? Imagine that you're gonna develop that in your computer when I send you the scripts. So like your copy is on your GitHub repo, mine is on mine, and so on. So we all have different copies of that.
We will create, like, if you create a new project with 04, so we will create a new repository again.
Yes. Yeah,
Why
so
not we don't put it the same repository? We do this.
it would be easier, but I don't want to do that. Because if you start mixing too many things in the same repo, I think it's harder to make sense of what's going on. So if we compartmentalize exercises, it's easier to follow. And also because keeping things smaller, it's easier to troubleshoot compared to you having everything in one project in GitHub, and then if something goes wrong, it's harder to troubleshoot. Yeah. So yeah, I guess going back to what Arminder said, and just to make the point again, now every time we do a new project, so we did 01 intro, 02 wrangling, we did that downloading manually, just working your computer. From this point on, 03 CRD and the other projects we're gonna have probably about 10 this semester. Each one of them, you're gonna have a local copy of that, but you're also gonna have a GitHub copy of that. And that's gonna be only yours, right? So it's not like my 03 CRD is the same for all of you. No, mine is just mine, and each one of you has your own on your GitHub repos. Yeah, so just so you're aware of that. And we're gonna be following this workflow. That's why I have these slides here, because next time that I'm just gonna come back here to the beginning of these slides. Next time that I send you, maybe I will say something like, send you an email saying, hey, create a GitHub workflow for an exercise called 04 RCBD. You're gonna follow these exact steps to do that. So you go to GitHub, you create that repo first, you name that 04 RCBD, you come to your computer, you're gonna copy that HTTPS, come to your computer, launch RStudio, do a new RStudio project, version control, Git, do all this, right? So this you're gonna be doing multiple times in the course, which is also by design. Because if you only did this today and you never did it again, you're not gonna learn how to do it properly. You're just following what I'm saying today. But from this point on, you're gonna be doing that a lot of times. Each time we do a new exercise, that's gonna force you to learn this for real and not just follow what I'm saying. Okay, any other questions before we move on? So our class goes until 11:30. I know for a fact we're not gonna be able to finish the next presentation today. So with that in mind, I do want to give you all a 5-minute break in case you want to get water, go to the restroom, stretch, whatever. So we're going to take a 5-minute break here and come back at 10:55 and then work until 11:30 on the next presentation, which is on experimental design. Yeah.
If we do commits multiple times in a day or in a week, we don't do push. But if I do push, everything will go with that.
All the code trees that you develop locally, that's not in GitHub, is going to go at once.
So it can be your like comment section. If I'm doing something, okay, I did this, what?
Yeah.
Now you have a better way to track us.
Yeah. That's right. Well, the goal is to help you guys, not.
And why don't we look at this person, it's just. I just had a this folder, and now I get 3 subfolders. PRNs.
How do you
But
put it?
our issue,
Yeah, because same format is not.
I will
So-
activity,
Hmm.
I did that. It was in this.
no, like set. you
And I
to-
moved it into. And it's not being seen.
Okay, so,
And it's hosted on GitHub. So
Okay.
even if I open it here, I can't push it.
okay. So what is going on here is, so where your art project icon is, that's what sets the main folder of that project. Because your art project is inside of code, it is in the wrong place, right? It should be one level up. So you should see your art project with the code data and all the folders in the same level.
Yeah.
So right now, it should be our project, data code, all of it. Right now, your art project is inside of code.
Okay.
So it's,
So-
you have that in the wrong direction.
Should I move it out?
Yeah, I don't know how, I mean, you can try to
That's
just
what
move
I'm
this
looking.
out into that main folder and see how that works and really only keep the code part in the code folder.
You were able to set up.
Yeah, you would need to delete from the code though, so it doesn't get confused. Now, what I would do is launch this art project here. And then let's see what happens. So now we're in the reference. Right?
Okay, so my, be like, it would be like HTTP, it can also be HTTPS, right? From what I don't know if I can. So it has.
So what you can, I mean, you can just try it basically, because it just made one change, right? So it was basically stage, you basically just edit your file. I mean, you can stage everything, I guess, right? If you wish. It seems like not maybe not. Maybe the first thing is, well,
So should I do
the first thing I would say is the scripts, right? I think I did this already. Yeah, so just stage everything.
Like everything.
Mhm.
So
If you click on that stage button, does that apply to all maybe, or? Yeah, okay, so then, let's make a commit. So we can just say something like moved our project into main folder. Work, right?
see the comments,
What comments?
comments.
Oh, the
Previous-
commits.
Yeah, the previous.
So there's a commit history right here.
What if you feel if you want, and just potentially work.
Nice, you know, what is already applying to research.
I actually started following this one, but yeah. Here is the option. After previous class.
Okay. That's nice.
I have already. I tried to. Yes.
Nice.
You know how I could change the. I want to make 7 into, there's one number 7.
What I would recommend is to change at the data level and not at the digiball level. So before you get into digiball, create a new column that's gonna say, if this column here is 7, then the new column is June or something like that. Let me get some water.
Give you the ability to actually
don't have the question left for them.
Yeah, but I think he's allowing that for some project might be, he might want us to give those our project.
Git clone also you can push.
But we, it's grown,
You can push it.
but you can push it into his repository. I think you can push it to yours.
If we add you as a collaborator, then you can push it.
Yeah, he has to add, but I think with fork and clone, you are already.
No, but you can't push them also. You will get, he will get a request.
Mhm.
But if you have to clone also, you will get a request, whether you want to separate or not. Weird situation.
It says that he set up, read that.
No, there's nothing is to do. Yeah, I don't forget. It too much. Nothing is from computer classes and all.
All right, let's get going with the remaining of the class. So the next thing that we're gonna do is start talking about experimental design concepts that are gonna be really important. And that I would imagine you probably have heard these already from previous stats courses. This is just a refresher. And perhaps you're gonna be, looking at some more applied examples that what I came to learn for myself is the more stats courses I took, even if there was repetition, the more I learned as I took more of them, because a lot of times when I heard something for the first time, my mind was not able to really understand what that meant. And when I heard it for the second or maybe third time, I really made sense of it. So maybe, if you have already heard about these concepts, I hope that today, can still learn something from this. All right, so this is on the class schedule on the website. This is the next presentation that's actually for today. I'm gonna go ahead and launch that here and start presenting that. Again, if you wanna download as a PDF and take notes, you're welcome to. If you wanna follow on your site, there's gonna be some links you can also follow there as well. Okay, so the first thing that I wanna go through with you is some very important experimentation concepts that I think if we have them understood correctly, it helps you to understand how your studies are set up. It helps you understand how to analyze your data and so on. So today we're not going to be analyzing data yet. That's going to be after we finish this lecture, but this is going to set a foundation so we understand why we're doing what we're doing when we get to the coding part, because you may know this already, that software, regardless if it's point and click or coding, it's going to give you results, even if you're running a terribly wrong model based on your design. So knowing your design and knowing how to translate that into code is going to be on you, on us as researchers. And this is part of that. Okay, so we're going to go through just an experimentation planning workflow, hypothesis setting. I'm going to talk about that. Talk about a study design. So you probably heard about treatment design, experimental design. A lot of times I feel like these concepts are not explained clearly in a way that people understand they're two different things and they are combined into the study design. So we're going to be making that distinction here. Also talking about experimental unit and observational units. This is a very important concept. So you make sure that you're running the right analysis. Because if you don't get this concept, it's easy for you to use subsampling as true replication, which should not be used. And it has true consequences on reproducibility and on the certainty that you have on your data. So we're going to be talking about that as well. And then we're going to discuss a couple of designs. So a completely randomized design and a randomized complete block design. I'm going to walk through these, when you use each one of them, what are their pros and cons, and that's it. Okay, so experimentation planning workflow. Even though I think some stats courses teach you this way, but to me, it wasn't very clear until later, and I wish that it had been clear earlier for me. I don't know how that's for you, but if you think about it, any design study that you conduct, including all the ones you're conducting for your researches, it really starts with the curiosity about a specific question, right? So maybe your advisor had this idea and they, found that this was an interesting topic. They did some literature review and then decided to create some hypotheses related to that question, right? So we're curious about this topic, we create some hypothesis, and then we use hypothesis to set our objectives, right? So those should be connected. And a lot of times I see, especially in graduate student presentations, especially I guess early graduate students in their careers, you go on a presentation, they have a poster, they have an oral presentation, and they never show you hypothesis or objectives. And then you just go through the whole presentation without really understanding what question they're trying to answer. And I think a lot of times this gets lost in our education, that we have to have hypotheses, have to have objectives, because that's what sets the stage of why and how you're doing what you're doing after that. So these are very important to keep in mind. After we have our objectives, then we create a treatment design that's going to address those objectives. So the treatment design, part of the design, is going to address your objectives. Are the treatments that you're choosing in a way that when you compare them, you can answer your objectives with that comparison. Also after we determine our treatment design, we have to define what is our experimental unit. I'm not going to get into much detail here, but that's a very important topic. Again, because if you know what is your experimental unit, that's how it defines what is your plot, what is your true application, what is your subsampling. Those are very important topics to understand. Once you know what is your experimental unit, you need to determine the level of homogeneity of the experimental material. If all of the experimental material is homogeneous, you can get along with a completely randomized design. That is, at least in field research, is not the most common. And I guess even in controlled environments, it may not be the case, because maybe all of your pots with substrate are the same, but maybe you have a place in the greenhouse that is warmer and the other one is cooler, depending where the heat outlet is. And that creates variability, right? And that variability means that your experimental material is not homogeneous. So we need to determine this. And the answer to this question then helps us understand what experimental design we need to address that variability and to account for it in a way that we still have power to find treatment differences in our study. This is kind of just like a visual of that. So really, on the left-hand side here, we start with the curiosity, with a question there. We base on that and on literature review, we create some hypotheses, and those hypotheses we use to create objectives. And all this is what we use to define our treatment design. So keep in mind, treatment design is the part of your design that answers your objectives. It has nothing to do with experimental material limitations yet. On the right-hand side here, we start off determining what is your experimental unit and how homogeneous or heterogeneous it is. And then we use that information to determine your experimental design side of the design. So two pieces of the design, treatment design, experimental design. They're doing different things in your model, and they're both equally important. Okay. So let's get into each one of these steps now and talk a little bit about them. So the first one here to really start talking is hypothesis. I have some guidelines here that I think I learned during my time as a graduate student, and I see that a lot of times even papers published don't get this right in a very simple way. So the hypothesis is what we use to formalize your belief about what you think is going to happen after you collect data. However, you create a hypothesis before you collect data. So you could be creating the hypothesis based on literature review, maybe on a preliminary study that someone ran, based on something, but you have to have the hypothesis in place. And that actually makes research more fun, because now you have something that you're going to collect data and compare against and see, is your data in support of the hypothesis or is it not in support of the hypothesis? Because we're using data to test this hypothesis, it has to be testable and you need to provide a right or wrong answer and not both. What do I mean by that? Your hypothesis need to be set up in a way that you use your data. So let's say you say that your hypothesis is that A and B are different, whatever that is. And then you go and collect data in A, B and analyze it, and you find that they are indeed different. So you are confirming your hypothesis, but perhaps they were not different. So you are, I guess, proving wrong your hypothesis, and that's okay. But your hypothesis need to be set up in a way that you can test it and you can say, yes, my data is in agreement, or no, my data is not in agreement with this hypothesis. So after you collect that data, you should be able to say that the data either supports, has evidence in support or against the hypothesis. And sometimes it does happen, and depending on who's writing and the writing style, they would say like, this was our hypothesis. We collected this data, and the data showed evidence against our hypothesis. So we update our, I guess, our belief about the system by using this approach. So it's okay if your data in the end shows that what you thought was going to happen didn't happen. That's part of science. Okay, so I want to put this up, and I want to be asking you to help me here with a few examples. So let's say that this is my hypothesis. We hypothesize that increasing nitrogen and potassium fertilizer rates will increase corn yield. So I want to ask you all first to think about it, and then I'm going to ask someone to help me here. Is this a testable hypothesis? And why do you think it is or is not? Okay, but I guess and maybe this is a little bit too early for you all to understand where I'm going with this. But is the way that I wrote this hypothesis testable? Can I say yes or no? If you collect data. So let's say you collect data, and
We
then
weren't specific enough with it, were you?
okay, so I'm hearing like specificity has an effect. Yeah, so I was not super specific, right? But I guess let me walk you through what I'm thinking here. So this hypothesis is testable because of the following reason. If I have treatments that we're going to talk about treatments later, but if I had the right treatments in my treatment design, so let's say I have multiple nitrogen rates, multiple potassium rates, and I go and collect yield data, and there is a difference, which I guess we would expect most of the time, especially in corn. I can say, yes, my data is in support of this hypothesis. The hypothesis is testable. If it comes back and there's no effect, which could also happen, I can say, no, nitrogen and potassium do not have an effect on yield, at least not in my study. I can say yes or no easily. It is testable in that sense, okay? I want to show you another example here. What about now? Is this a testable hypothesis? So let's say collect data and there is an effect. Then I come here and say, okay, that is in agreement with my hypothesis. But if I collect data and there is no effect, that is also in agreement with my hypothesis because of one thing here in this sentence. May, right? So this may here make this hypothesis very weak because whatever it comes out of my study, I can say, yeah, it may increase or it may not increase. It was my hypothesis was open like that, right? And I see this a lot where hypotheses are very open-ended and not open-ended in the specificity, but open-ended in like, if I get data that says yes, then my hypothesis is true. And if data says no, my hypothesis is also true. So this is a weak hypothesis. And I guess I really learned more about this when applying for grants, for national grants, because they really nail down into this. Do you really know your problem? Are you really clear on what is your hypothesis? And we see on those workshops saying, do not use these weak words that show that your hypothesis is open and whatever happens with the data, it fits in the hypothesis, right? So imagine that you are making an assumption here. You have to be bold and say, this is what I think is going to happen. And if it doesn't happen, fine. It doesn't have to happen. But at least you have a starting point that you can test against that starting point. So hypotheses need to be a bold statement and it needs to be testable, even if you are wrong. Okay, maybe a little bit or different wording, but is this a testable hypothesis and why? It is? So anyone else has any thoughts? You think it is testable or not?
It's tested.
It is? What do you think?
If we increase, we will, if we will increase, we will accept the hypothesis. If it doesn't, then we reject it. But
Yeah,
if it stays same, then it's a problem.
So, and and maybe this is a little bit more subject to interpretation as well. In my opinion, what makes this hypothesis non-testable is that can. Because if it can, but it kind of leaves it open that like, well, I said that it could, but it didn't, so I'm still right. Because it didn't say you will, like I didn't say it was a hard statement. I said it could potentially, hopefully, so it was kind of like still a weak hypothesis in that sense. So we really want to be very bold with our hypothesis, because that's what it should be. A hypothesis should be that way. Okay, so we have curiosity, we set our hypothesis based on that question, and now we create our objectives. Our objectives should stem directly from our hypothesis, right? So here, if we have a hypothesis that says we hypothesize that increasing N and K fertilizer rates will increase corn grain yield, my objectives should be connected to that, right? So you should say something like, our objective is to assess the effects of different nitrogen and potassium rates on corn grain yield. So you see how they're very well connected, right? And this, I think it sets your work up to be easily testable. Because if you have a very open-ended hypothesis, and then you have objectives that don't directly connect to them, it may be more difficult for you to really understand what you were doing and even more convince your audience of what you did. So I don't know, the more you read and the more I guess you're going to see this, but to me, the papers that are really good to read are very easy, flow well, are ones that, have a lot of different things in common, but one of them is that they have very clear hypotheses and very clear objectives that are connected, and it's easy to test that with the data that they show. Okay, so study design. As I was telling you, a study design is comprised of two components, the treatment design and the experimental design. So let's get into those a little bit here. And just to give you also another comment, as you're reading papers or you start to review papers or you start to write your own papers, this is another piece of your paper and papers that some people, I guess, don't get it this way. So they would say, well, my treatment was, a factorial of some sort, and they stop there. They never tell you the experimental design. And that is not really good, because then you're not quite sure how that analysis was run. Because really, as you're going to see when we start coding, knowing these very clearly, even before you run your study, is going to help you to very clearly define your model. And if you define the right model for what actually happened on your study, that is what you want to do. Because it's very easy for you to go out in the field and do one design, let's say a CRD, and then you come to, or maybe let's think the other way. You do a randomized complete block design. If you don't know what this means, we're going to get to it in a second here, but you do that design, which is a little bit more complex. And then you come to your software, collect your data, come to your software, and you run that with the code that actually reflects a completely randomized design, but you don't know about it. Neither does R or Python or SAS. So you just then publish this great data with the wrong design analysis. So if you don't tell me what you did on your material methods and what was the design you used, I'm not going to be able to check your results and understand if whenever you show me your results, I should be able to go there and say, okay, I see degrees of freedom here. It's matching, it's doing what it was supposed to do. What they told me they did is what actually I can see here. So that information is important both for you to make sure you're doing the right thing, but also for audience to know that you did the right thing when they're reviewing and going through your work. All right, so let's get into the treatment design part of that. As I told you already, and I'll be telling you many times today and potentially next class as well, treatment design is the part of the study design related to what treatments you need to answer your hypothesis and objectives and how they're related to one another. So remember, treatment design is only addressing your objectives. That's the goal of the treatment design. And overall, we want to select a treatment design that contains the treatment factors and their levels that are needed to answer the research question and your objectives. So let's say if I want to say that I want to test the effects of nitrogen potassium fertilizer rates, well, we're gonna do this exercise a little bit later here in the presentation, but you can already be thinking of what should be your treatment levels, right? Should I use one nitrogen rate, one potassium rate and do that? Should I choose multiple rates? You know, I hope you're thinking about this in the way that you start with a question and then you determine your treatment design in a way that you can answer those questions, right? Okay, so I guess this is where we do this exercise. Let's just stop here for a second and think about it. If I tell you that I want to find the optimum amount of an input, it could be fertilizer, it could be water, it could be seeding rate, it could be, you know, temperature in a greenhouse, humidity, anything like that. I really need to treat the crop with different levels of that input, whatever it is, so it can estimate at which point that your response is maximized. So this is one analysis that is very common across agriculture studies, where imagine you would have, so let's say in this case, we're talking about fertilizer. So we'd have fertilizer rates on the x-axis and then yield on the y-axis. You would expect to see most of the time, not always, but a quadratic response, right? So as you increase fertilizer rates, I'm assuming that's limiting, you're going to increase yield until a biological limit, and then potentially decrease yield if you apply way too much of it. And that happens with most of the inputs. So it could be, you know, all these things we talked about. We see that type of response because we're working with biological systems. In our case here, since we have two inputs that we're using as an example, so nitrogen and potassium, we need to do that for both of them. Also, something else that normally happens in these types of studies is that there could be an interaction between these two nutrients that I'm talking about. So maybe nitrogen and potassium interact between themselves when they're impacting corn yield. So we want to explore that interaction as well. So assuming that we have two treatment factors, nitrogen and potassium, now let's think about their levels, right? So I mean, I have something after here if I click my forward button, but I just want you to be thinking about it. What levels would you choose, perhaps? Well, not what level specifically, but how many levels would you choose to test or for this study that we're setting up for nitrogen and potassium? How many rates do you think we would need for each one of them? There's no wrong or right answer.
Minimum.
At least three. Okay, I agree. So I'm proposing here just as an example that we would have a 0, 100, and 200 kilos of nitrogen per hectare and a 0, 30, and 60 kilos of potassium per hectare. This is going to allow us to explore this variability in rates and how that's impacting yield. And really, I think I agree that 3 is probably the minimum you would go, but the more, the better, if possible. And just to make a very clear distinction here that I think sometimes it gets a little bit lost. So when you're reading papers and they're talking about treatment factors, that's the column name if you think of a data set, right? So that's like potassium and nitrogen fertilizer. And then if you think about levels, that's what comes under that column name. So there will be what values you chose for those factors. Those would be the levels, right? So the 0, 30, 60, those would be levels. So treatment factors and levels are different things. I just wanted to make that point here. Okay, so moving forward in our example here, since we are interested in how they interact, we need to have in our treatment design all the combinations between those 3 nitrogen rates and 3 potassium fertilizer rates. Right, so since we have 3 levels on each, that means that we're going to need 9 total treatment combinations on this treatment design to answer this question, right? So the question being, does nitrogen, potassium alone, but also together affecting corn yield in the end? In other words, we're just going to need all of those 9 treatments to find the optimum points that optimizes yield here. And you know, you would normally see this in papers as you're reading the material methods part, that this would be, it can be called a few different ways, but it could be like a cross 2-way factorial because we have 2 treatment factors that we're crossing all of those levels. Could also, you know, another way that people may refer to it and be more clear is that you're using a crossed, and then they say the number of levels for each one of those factors. So across 3 nitrogen rate by 3 potassium rate factorial treatment design. These would be some of the ways that you would be referring to this type of design when you write or when you read papers. A point I want to make here is that note that I use the word crossed, and that's an important aspect here, because when I say that something is crossed, it means that I have all combinations between them, but also it means they are on the same importance level within the design. That's what we're showing here on this example. And just by contrast, I hope that you have heard about this already, but these factors could have been arranged in a nested way. So not crossed, but nested. And if they're nested, it's normally, well, I guess a very good example of nested treatment effects or treatment design is when you have split plots, which we're going to be talking more about in another lecture of this class. But in a split plot, you may have the same factors, same levels, but now one is more important, not more important, but is applied on a different area size than the other. Because of that, this has implications on how you analyze this data, how much certainty you have about those effects, and so on. So just wanted to give you that contrast that right now we're talking about crossed because both factors have the same importance or are at the same level of hierarchy in this design, but they could have also been nested, which is the case of a split plot design. Okay, so, we're talking about treatment design. I hope it resonates with you that we're only addressing our objectives. That's what the treatment design does. So what is the use of the experimental design and why is it important in our analysis? So the experimental design is going to be the part of our design that is going to be related to how your treatments are assigned to your experimental units. Experimental unit is also a very important concept we're going to be talking about soon, so with experimental design, it sets how we randomize treatments to plots or whatever. And really, we decide on what we should use based on two main factors. One of them is, again, the homogeneity of the experimental design. The second one is limitations. So, maybe you're limited in funds. Maybe you don't have enough space in the incubator to run a lot of things. Or maybe, you have benches that you can only fit a certain number of pots on it. Or maybe a size of a field. Maybe, you really needed 2 times the size of the field to run what you wanted, but you only have half of it. So, those types of limitations in homogeneity or lack of it are what the experimental design part of the study design is going to address. And our goal here is to use the simplest experimental design that will accommodate all of our treatments and their replications in homogeneous experimental units. That's the key there. Our design is going to help us do that. Even if you have heterogeneous material, your design should account for that in a way that you're still allocating your treatments within homogeneous units. Okay, so we're talking about experimental units. What is an experimental unit? Let's define that first. And that concept is going to be really important because, again, what is an experimental unit for me may not be the same as for you, depending how you're applying your treatment. And knowing what is for your case is going to be important to set the right model and to know how to run your analysis in the right way. So experimental unit is the smallest unit in an experiment that is randomly and independently assigned to a treatment. If you think of field research, this is normally a plot, right? And is a unit of true replication. So in this case here, I just have an example. This is a plot between the 2 flags. The treatment is being applied to the whole area here. And that is what sets my experimental unit. If this treatment was being applied only to a few plants, maybe those plants would be my experimental unit then. Is the level where you are applying your treatment at. That is what sets your experimental unit. And there's a difference, though, between experimental unit and observational units. Observational unit now is what you actually use to measure the outcome of whatever you're doing, right? So let's say in fertilizer, I go in and apply my treatments to the whole plot, but very rarely I'm going to be measuring everything from the whole plot, right? I'm normally going to be taking soil samples, maybe we're going to be taking plant samples like we have here. So our observational unit then is not the same as our experimental unit, right? So observational unit here would be pulling 6 corn plants for yield estimation, or maybe estimating biomass or something else, or maybe pulling soil samples, that would be your observational unit. And one of the main points here to make is that I can come here and make a plot that is huge. For whatever, like just think whatever you're working with, just think 3 times that time, that space. And then I go there, and because it is a large unit, experimental unit, I go and take, instead of just 1 bundle of 6 plants, I take 10 bundles of 6 plants within that experimental unit. That, my friends, is subsampling. And that does not give you the same statistical power as if instead you had created more independent experimental units. So you're increasing your number of observational units within that experimental unit, but statistically it's going to help you very little. And this is another important concept. So again, experimental unit is the level that you apply your treatment. Observation unit is what you're measuring. And a lot of times people do subsampling, which is taking multiple samples within the same experimental unit and treat them as true replicates. And that is wrong. It's wrong analysis. You don't want to do that because you're doing subsampling, and that should be treated as such. Okay, a couple more concepts here of a replicate. So a replicate is really just different experimental units that are receiving the same treatment. This is, most designs have replicates. The designs we're going to be looking at have replicates. Some designs may not have as many replicates as normally we use in field research, but that's what that would mean. And then there's also blocks. So, we talk about plots, we talk about blocks. I know that sometimes can be confusing. So I just want to make that distinction. A block in statistical terms or in design terms is a set of experimental units that are grouped into homogeneous conditions, whatever that means. You're going to see one example here, where each one of those experimental units is randomly assigned to a different treatment. And then randomization happens independently for each block. I know this is a mouthful, and you may not be following along exactly everything I'm saying here, but this will come back when we actually run data and run these designs in R. You're going to see how this makes an effect and how all these words kind of make sense when we're actually doing the randomization. So I'm just showing you here an example of a design where we have, so here's block 1. We also have block 2 here, but for now we can just focus on block 1. So in our example, we have 3 nitrogen rates, 3 potassium rates, meaning that we have 9 treatments, which I'm showing you here, numbering them from 1 to 9, where we randomize them inside. So each one of these cells is a plot or an experimental unit that's receiving a random assignment of a treatment, and they are grouped here by a block. So if you think block is the largest unit, we have 3 or 4 blocks normally in studies. So we have this replicated as well. So here would be block 2 right next to it. We have a block, we have a plots inside the blocks, and then we have our plants inside of the plot, which then are our observational units. So just a little bit of the hierarchy in case, this wasn't quite clear for you. I just wanted to make that clear. Okay, I think this is probably a good point for us to stop today, and we'll keep going next class period. So next class period, we're going to finish this lecture, and then we're going to go through some code of how to run CRD analysis. All right, so before you all leave, let me get your attendance on GitHub. For this, you're still going to have to go to GitHub. There's no way, because issues is a GitHub thing, is not a Git thing. So let me get your attendance. All right, I just created that repo. So go ahead, or sorry, not the repo, that issue. So go ahead and claim your attendance. If you have had any issues with Git and GitHub, we can try to troubleshoot that. Let me know, and we'll get together for it. All right, well, thanks everyone, and I'll see you on Tuesday.